Okay, this problem asks you to move some sliders around, and I'm just going to show the solution. I'm going to write my equation, the solution to these three questions down here, 1, 2, and 3. Okay, so we're just going to read it out loud. The table gives an average weekly earnings for Canadians over this 5-year period, where T is the number of years since 2002. So in this table right here, 0 is the year in 2002, that's 2003 and 2004 and so on. It says use the sliders to fit this exponential function. So I've plotted, these points have been plotted for you, and you can see that it's kind of slightly trending upwards. But if we look at it, it's not growing linearly. It doesn't grow by the same number each time. It does look like it in the graph here, but remember, we're zoomed way out. If you zoom right in, it's not growing linearly. You can also verify that by the first differences. So we've got an exponential function here, a times b to the power of x, and I'm going to manipulate a and b so that it fits this nice kind of this function. And then I'll write down the values for a and b in the equation itself, and then do problems 2 and 3. First off, so I notice it starts here way up, and which means when it's 0, it's 679. So the y-intercept here is 679, which means my a should be 679. So I'm going to move this way up here to actually be 679, if I can fit it right in there. And something you can do on Desmos, if you're really used to it, you can click right in there and change it to the exact value you want. Next is I'm going to play around with the b so that it fits nice and smooth. It tries to fit like a curve of best fit. Now you can play around with this too, so I could say like 1.02, that fits pretty nice, but it looks like it's increasing a little more. So I could say 1.03, that's probably alright. I could drop it down a little bit, but I'll keep my 679 there. So that's our curve, so I'm going to write that down for my answer to step 1 there. And then we'll use it to predict the earnings in 2010. So I've got a sheet here to do that. Here we go. So let's write that down. So let's say earnings as a function of time, and we'll use t in our equation. This is 679 times 1.03 to the power of t. So there's our equation that we came up with on the Desmos graph. Let's use it to predict the earnings in 2010. Okay, so in 2010, that's going to be 8 years after 2002. So we're going to plug in 8 in here, and then we're going to use our calculator, plug in 8 here. We'll use the calculator to crunch that out. After doing that, I get 860, and since this is money, we're going to round to 2 decimal places. I have 13688, so we got 14 cents here. So the earnings in 2010, the average weekly earnings in 2010 should be, by continuing this pattern, $860.14. Now let's predict when the average might be 1,000. So that means the earnings are 1,000, and we want to know when 679, 1.03 to the power of t. So what value of t is going to give this? So let's solve this. So to get this isolated, we're going to divide both sides by 679. So we've got 1,000 divided by 679. That's going to equal 1.03 to the power of t. So 1,000 divided by 679. Let's write this out. We got 1.473. Let's round that, and that's going to be 1.03 to the power of t. So now we're going to just try values of t that work. So I'm going to make a little table over here to kind of keep track. So if I try, let's see, if I try 1.03 to the power of 2, I get something very small. I get 1.06. So 2, I got 1.06. So let's go a little bit higher. And we also, that doesn't make much sense, because 1,000 is more than our 8. Like we put in 8 and we got 860, so we should be higher up. And we'll go verify with the graph after. But if we don't have a graph, we just plug in and solve. So let's pick, let's say 10, see what happens. So we've got 1.03 to the power of 10. and I'm getting 1.3, so 1.34 worked here. Okay, so that's what I got there. So we got to go a little higher, so let's try 12. I'm getting 12 got me 1.43. So I need to be a little higher. Let's try 13. And I got 1.47. It was 468, 47. So let's try a little bit higher, like 13.5, and see what happens. It's 1.03 power of 13.5. We're getting 1.49. We're a little higher than that. So we're in here. Let's try 13.25, half of that. So I got 1.479. So let's just try so let me write that in. 479. Let's try 13.2. I got 0.47, so let's just say 1.4. That was 1.477. One more. Let's do 13.1. I got 1.473. So T is going to equal 13.1 years. So what year will that be? Well, that will be 13.1 years after 2002.